For problem numbers 2 through 5, we want to use our key relationships here that we've talked about. And here we have rectangular, so find the rectangular coordinates. So that means that these are polar coordinates. So the 4 is the r, the 5 pi over 6 is the theta. And we know that if we want the x, that's r cosine theta. So the r is 4, theta being 5 pi over 6. We know that the cosine of 5 pi over 6 is negative radical 3 over 2. So we get that x is equal to, 2 goes into 4 2 times, and so we get negative 2 radical 3. And the y being 4 sine theta is 4 times the sine of 5 pi over 6, which is 4 times sine of pi over 6 is 1/2, and 4 times 1/2 is 2. So the coordinates are x being negative 2 radical 3 and y being 2. So for number 3, let's do this down here. X equals r cosine theta. And the cosine of negative 2 pi over 3, so we have 1, 2, negative 2 pi over 3, that's negative 1/2. And 8 times negative 1/2 is negative 4. Y is 8 times the sine of negative 2 pi over 3. And we know that the sine of negative 2 pi over 3 is negative radical 3 over 2. So that gives us negative 4 radical 3. So therefore, the x, I always do the x first, negative 4 comma negative 4 radical 3. Now in problem numbers 4 and 5, we're given the rectangular coordinates, find the polar coordinates. So we have an x and a y. And for these, I like to plot the points, 1, 2, 3, 1, 2, 3. So we have the point 3, negative 3, and that's down here. So I like to go ahead and make a right triangle like what we've done before. So in making this right triangle, we know that the lengths of the sides of the right triangle are 3 and 3. That means that we have an isosceles right triangle, which means the angle measures from geometry. Remember, the angle measures have to be the same, and if they have to be the same and the three angles add up to 180, each of these angles has to be a 45-degree angle. So that makes that angle a pi over 4, which makes this angle 7 pi over 4. And we also maybe remember from geometry that in an isosceles right triangle, the length of the hypotenuse is a leg multiplied by radical 2. So r equals radical 2, theta equals 7 pi over 4. And so we have, 3 negative 3 equals r is negative 3 radical 2, and then theta is 7 pi over 4. And those meet the conditions. The r is positive and the theta is within the unit circle. So we can move on to the next one. Now, let me zoom in a little bit for this one. For problem number 5, we've got to really be careful here. R is a negative, and then theta, this is kind of an interesting theta, has to be in between negative pi and pi. So we'll talk about that in a minute, but let's go ahead and graph this. We're going to be in the third quadrant, negative 5, and then negative 5 radical 3, wherever that is, somewhere down there. But here we'll put it just there, and then we'll label the triangle. So we know that that side has length 5. This side has length 5 radical 3. There's a theta in here. It's going to get us into that quadrant. But if we want to find r, we know that r squared is x squared plus y squared. And x squared would be 25. And a y squared, 5 radical 3 squared. Let's do that. Let's just write it down so we can visualize it a little bit better. So 25 plus, now 5 radical 3 squared, 5 squared is 25, radical 3 squared is 3, 25 times 3 is 75. So that's good. So we have r squared is 100, so r is plus or minus 10. Normally when we're dealing with a hypotenuse, we would just use the positive, but it does say that r has to be negative, so we're going to use the r equals negative 10 because of that condition right there. Now the theta, we're going to go ahead and use the tangent of theta equals y over x as our way of finding theta. Now the y is negative 5 radical 3, and the x is negative 5, so we get the tangent of theta is radical 3. Well, we know that that happens to be when theta is either equal to pi over 3 or 4 pi over 3. So if we know that, then we have to just make sure that whichever angle we select is the condition, meets the condition that we were given. And if we're looking here, we notice that, well, 4 pi over 3 is greater than pi, but pi over 3 happens to be in the same, in this interval. And if you think about it, if we want to plot that point right there in the third quadrant, then what we would do, so the r theta, what we would do is we would go away from the angle that's in the first quadrant, which is the pi over 3, and so we would say that r theta is negative 10 comma pi over 3. And that's it. Let's put a box around that. And might as well box this one as well. Hey, while we're at it, let's go ahead and box all the answers here. Where's that other one? There it is.